Um, share my screen. All right. So a warm welcome to everyone who's joining us today for our 1.5 hour adventure focusing on some non-basic features of Git. Now, I know the event is happening virtually, but all of us are situated at different locations across Melbourne, but we're still on Australian soil. So I would like to first start by just acknowledging the traditional owners of this land and recognizing the continued connection to our land, its waters, and its culture. We pay our respects to the elders past, present, and emerging. Now, before we actually dive into the workshop today, I'll briefly talk about who we are and what we do, because we are a relatively new club. So Google has an initiative called the Developer Student Clubs, and we basically their representative at Monash University. Our focus would be mostly on sharing our knowledge about popular and emerging technologies in the tech field. And just a fun fact, this is the first year that Google is actually bringing its Developer Student Clubs community to Australia. So it's pretty exciting to be part of this program. Now, our team is quite small. It includes me and two amazing people, Mohit, who is our DSC lead, and who you'll hear from soon because he's leading the workshop today. And we also have Jaskirat, who looks over the workshops, the administration tasks, and general organization tasks. You'll get to hear from her soon as well, towards the end of the workshop, to talk about some of the positions we have open in our team. So stay tuned for that. Yep, so that was just a brief overview of who we are. And now I'll hand it over to Mohit so we could get started with the more exciting stuff.
Thank you, Kunj, about this. Okay, yep. Is everyone can see my screen?
Yep.
Okay, cool. Okay. Hello, everyone. My name is Mohit Sharma. I think Kunj already introduced myself as well. Like I'm representing the DSC. I'm the DSC lead here. So our main agenda of today's is like Git Beyond basics. So first we're going to talk about what is the version control and what are the different version controls we have, like CVCS, DVCS, or short history, and how to install Git. Then we talk about the first time Git setups, like when you're going to install for the first time, what things you should remember it. And then we're just going to talk about some of the Git basics like commit histories, tagging, Git Aliases. And in the last, we're just going to talk about the starting with the Git branching, merging remote branches and rebasings. This workshop is going to be too long, so I decided to make it in 2 workshops rather than in just one, so that you guys have more better understanding about the topic of Git. So before I move on to Git and why we need Git in our day-to-day life, it's better to start with the versioning control. Okay, so starting with the version control. So version control, what is the version control and why should we care? So like if I talk about like in earliest like 2004 or 2005, at the time when the version controls, these things comes up into the development side. So people have like, just for example, take an example, like you are a graphic designer in your particular company, and you have to maintain, like if some of the graphic designer is just editing some images and you want to restore every of the images, whatever the changes they are making each and every time. So what you will going to do at that time, like you don't have any resources. So you take the particular image, you copy that image into one directory, and another time the graphic designer make any changes, then you again do it same way. So it's kind of a very long process and it's not going to work for too long. So that's the came of the version control initiative. You can say the initiation started at the time. So I just said like this way. So I'm going to talk about we have like 3 different types of the versioning control initially starting from the 2004. So I have made this graph for you guys. So let me just show you. Okay. So earlier, like we just example that in early 2004, you are not living in like 2020 right now. So you are in 2004 when you have to work on your local computers. You don't have any internet, you don't have any servers where you're working on. And now you want to uh, control about your versions of particular things, like it's irrespective to files. It may be your images, anything can be any kind of a file it can be. So one of the problem with the local version control system is that like this is a very common approach which used by a lot of people at the time. And the main issue is like when you have to maintain the particular image or the version of the file, every time you have to create a new directory at that time, and then you have to make a new directory, copy and put the file again and again. So it's kind of a very shitty process, to be honest. So one of the most popular VCS tool, which is the version control systems at the time, was introduced is the RCS, which is the remote control systems they introduced, in which they said it's better rather than putting every time creating a like version into a new directory, just use the database inside your local computer. So they come up with this thing. So every time, whenever you have to store the version of a same file, like you added today, now you're adding after 5 hours, then you add it again and again. So you can just create a database and put there directly the file. So now, okay, it's working fine. People saying, okay, it's looking good. We can work on my local PC. But now what? Like if I'm working, I'm a developer, you guys are a developer. Now you want to collaborate with other developers and you want to share the same repository with others. You're working on some project and it's genuine, like you working on your home, somebody's working at their home, and you need to collaborate on the same project. So with this thing, you cannot work, of course. So they come up with the new feature, which is the centralized version control system, which is the, in terms, better as compared to the local version control system. But the major issue is here is like it's totally depending upon one server. So let's suppose this developer is working and pushing and pull, everything is doing here. This developer is also doing same. This developer is doing the same. But anyhow, chances that only we have one server. So what happened if this server dies, or any natural calamity happens, or anything happens through which the server dies? So none of them you can work, and whatever the version history you're saving, it's not going to be saved. So that's the major drawback of that particular centralized version control systems happen at the time. And I don't know, like you guys have ever worked before on like CVCs or the subversions, which are the most popular at the time. And now in today's world, we use the distributed version control systems like Git or Bazaar, Darks, if you have other use except of Git. Git is more popular as compared to other ones because it's easy and it's highly scalable, and really in terms of speed performance, it's really good. So why we are using Git today is just because of its speed, scalabilities, and performance wise. So how the distribution version control systems work is like you can like one file with multiple versions of the same file you can have. And similarly, you can collaborate with your developers, and you can send the particular file on the server along with the server have different versions of your same database. So that's it about like now the different versions control. I'm just going to move to the installing a Git. The reason how Git came into the market, or you can say came into the idea of the Linus Torvalds, who's the creator or the founder. So what he thought of, like there is a company, there is a relationship between the community who developed Linux kernel, and there is a commercial company who developed the BitKeeper. The BitKeeper is a company who initially used this distributed control version, the one which I show you. So BitKeeper is also one of the DVCS at the time in 2004. But now the company had some relation, like they have some broke down, like in some of conspiracy happening, and they don't have any more bonding with each other. So they broke down their tie-up and everything. And then at the time, like most probably the Linus Torvalds, creator of the Linux, developed his own tool. So because he learned some lessons from that, because they're depending upon the BitKeeper initially, so they come up with this Git in 2005. And if you some of people have a myth that Git it is a product of GitHub. It's not a product of GitHub. It's an individual. It's a part of Linux who developed basically the Linux store world, who's the creator of Linux, who developed Git because of this whole conspiracy happened between the two companies, BitKeeper and the Linux kernel community who developed Linux. So some of the goals of this new systems at the time they developed is the speed, simple design of the Git, ability to handle large project in Linux kernels, efficiencies and everything. So since its birth of 2005, Git was evolved and matured. Now you're using Git. So now comes to what is Git. So Git is a free and open source distribution version control designed to handle everything from small to very large project with the speed and efficiencies. And Git is easy to learn from tiny footprint with a light, fast performance. Okay, I believe now you have understand what's the different version controls and why do we need the version controls so that every time you made any changes, you want to see what changes somebody has made in terms of developer, in terms of a graphic designer, and anytime you want to go back for particular file so that you can see the changes or revert it back because some issues arises. So before moving forward towards the installing Git, I would like to talk about the snapshots and not differences. The major difference between Git and other VCS is that Git thinks about its data, and you just imagine like every time whenever you create any directory in particular your computer, PC, anywhere, Git always going to take a snapshot of that. But other VCS like the CVS, Subversions, Perforce, what they do, like they think as a file system. So whatever the changes you are making, they will going to change made over the file over time. And this is commonly described as a delta-based version control. They don't create the particular snapshots. They're just going to create like whatever the changes you are doing, it's going to store in that. And that makes the Git very different from other CVS or you can say VCS systems. So Git never think of like storing of its data this way. Instead, Git thinks about its data more like a series of a snapshot. You can think of a snapshot as like just taking a picture. Every time you add anything, you commit anything, you made any modify, change anything, it's going to be considered as an image. So it's going to store your images. It's kind of images, but it's not an image. It's just an image, which is going to be stored in your particular, inside your local directory. Okay. Now, why one of the good thing about the Git is about the Git has integrity. What does it mean? This I'm going to explain later as well, like what this hash code is representing. So everything in Git is a checksum before it's stored, and it is referred to as a checksum. What does it mean? It's like it is impossible to change the content of any file or directory without Git knowing about it. So the functionality of Git has the lowest level and it's integral to its philosophy. You cannot lose any information when you are doing anything in between the transit to get a file corruptions without Git being able to detect it. The most of the mechanism which is used by the checksum is called the SHA-1 hash value. This is a 40 character value, which is lie between this value of 0 to 9 and uses the alphabets A to F and calculated based on the content of a file and the structure. I'm going to show you this value just on my terminal right now, but later on, I'm going to show you like how this hash value looks like and what's this important value represent. Always remember, like whenever Git has to refer to any value or refer to any file or anything, Git use this hash value. So you will see this hash value all over the places I will do, but in Git stores this everything in the database, not by the name of file, but by the hash value. Okay, now come to the 3 stages I'm going to talk about. Like these are the main 3 stages, and I would like you to, if you can put more attention on this ones, like the 3 stages are the modify, stage, and committed. What does it mean? Like modify means like the changes you have changed in the file, but not committed to the database. And the terms database here means like inside the Git hidden Git directory I'm referring to. So second one is the stage means like you have marked a modified files in a current versions to go to the commit snapshot, and the committed means like the data is safely stored in your local database. This leads us to 3 main sections about the working staging areas and Git directory. don't worry about like if you don't understand what is the staging area or what is the working directory or the Git directory, because I'm going to show you everything on the terminal, so how it's going to look like and everything. So installing a Git is pretty simple if you are a Linux user. So if you have like Fedora or Red Hat Linux, so you can just use sudo dnf install git all. But if you are on Debian user such as Ubuntu, you can use sudo apt install git all. For Mac and Windows user, my preference for the Mac user, if you have Xcode terminal, then you can, it's automatically installed. And when you're going to type this command, the git ---- version, it's going to show you. If it's not showing you, it will going to prompt you to install it on Mac users. And for the Windows users, you have multiple ways. Either you can just download from this particular link. And don't worry about the slides, because each slide is going to be shared with you as well on our platform. So you can download if you want it later on. Or you can use in Windows like the Git Chocolatey package from from the GitHub. Or you can use the Git Desktop, which gives you more interactive GUI if you are like kind of don't like the terminals and everything. So you can go for the GitHub Desktop. Okay, for the first time, like when you set up the Git setup, this is one of the most important thing. Now I'm going to start with this thing. Just give me a minute, because I'm going to open my terminal alongside it, so you can see what's going on. Okay. I believe you can see my things. Okay, just give me a minute. Okay, so now you know like what is the version control, you know about like how Git came into the idea of Linux, who the founder of Linux worlds. So why we are using Git, because it's the most faster and good of distributed controlling version way. So whenever you install Git, it comes into 3 different configurations. Either it's going to be inside your path, inside the etc directory, and it's same for all 3 users, Windows, Mac, and Linux. And most of time, whenever if you have used before Git in your life, you will most of the time, whenever you create a directory, you will see a hidden directory here inside your particular folder wherever you initialize the Git. So right now, like this is my hidden Git directory, which is created. And it's similarly, if you are a Windows user, you can see opening the, showing the hidden files, and you will going to see every time whenever you do the git init command, it's going to show you the Git, it's going to create automatically the Git hidden directory for you. So these are the 3 different ways. Mostly I'm going to focus on this one, because every time whenever you create a particular directory and initialize the git command over there, so it's going to be working here, and we're going to see this one. And in this, like you have the config file inside the Git, which I'm going to show you just right now. So you can see this config file over here, which contains all the informations regarding who you are, what is your remote origin, what is your branch master right now. Don't worry about if you don't understand anything, like what is the remote origin, branches, or what is this information is telling you about. So for the whole this workshop, I'm going to just stick with this this config file and towards the .git init directory. Now I'm just assuming like if you have installed here, so you can see whether you have installed the Git version or not. So I'm using the latest version of the Git right now, which is the Git 2.28. This is the latest version which just came recent into the market. And now before jumping towards your identity, whenever you install the Git, it always good to set up your username and your user email, because it's good, like this is used for like every time when you're going to commit anything or push anything to the servers, you have to refer to your username and the email ID through which you are pushing it. So just imagine, so right now, like I'm just going to show you, like I'm just going to add my username. So using the git config -- global user .name, I can add any name, like if you want. So I'm just going to add my full name. So just right now I added my name. I can edit my email ID. Okay, so So my email ID is also added. So what does it mean? Like now every time when, and I'll tell you the git config command, the one which I show you above inside the config file, this one where we just working in. So in this config file, inside this particular directory, this information is now stored. And what does it mean? Like now, every time if I'm going to push anything to the particular GitHub, GitLab, anywhere on the particular repository, this information of the username with the Mohit Sharma and this particular with the user email ID. Oh, I added this one by mistake, my bad. It's going to be email ID, not the name. Okay, yeah. So it's going to be referred to these things, okay? Now, if you interested in seeing about your particular what config list you have, you can see using the git -- list command -- show origin. So it's showing you so many things. So just focus on the top one, which I created just right now, like on these two things, because we just added these two, because if you never done anything and when you install for the first time, you only going to see this two things inside your config file, which is your email ID and your username. Okay, now, once you have set up this thing, so now you can choose your editor choice according to your own needs. Like I just like you love Node++, if you are a Windows user, if you love Vim, it's up to you. I love Nano, so I'm going to stick with the Nano. So when you install for the first time, by default, Git choose the automatically inbuilt editor. If you're using the Linux or Mac, probably it's going to show you the Vim or the Emac, or otherwise if you are Windows users, you can set up using this command for the particular, if you're interested in setting up the Notepad++. So I'm just going to set up here this global editor. Using the global that you're saying everywhere, wherever I use the particular command in the directory or in the system, it's going to be same for everything. If you remove the global command, it's going to be work only for this particular directory, not outside this directory. So I'm putting everything globally. That means that everywhere I'm going to run git config or doing editing anywhere, it's going to be added in using the nano command. So I'm just going to type git config -- global core.editors.nano. So now I have added everything. We're going to see how it's automatically going to open Nano later on. Just right now, we are just putting some of the configurations before we're going to do some initiation or creating a new directory or doing some push pull. So it's better to just do some of the basic things before you start doing anything. Okay. This feature comes from the 2.28, the one which I'm going to talk about right now. Previously, whenever you using the by default, Git will going to create a branch called a master. Master is nothing, it's just a branch. Don't assume it. Some people have a myth like master is the main branch. It's not like this. You can change the name and you can put anything. Whatever you want to, like I'm going to show you right now. So like a git config global init.default branch change to like my DSC branch. So it's nothing like that. You can't change anything. It doesn't matter. Like it's not going to tell you about which branch you are using right now. Okay. So now believe if I'm just going to show you. First, let me just see initialization is already done. Okay. So let's just see git config -- list. It's going to list all of your username directory. So if you see, like I have added so many times, that's why it's showing you like this. And you will see here my username. I think it's username is again using that things. I'm going to fix that thing. Okay. Okay, it's look good to me. Okay, just give me a minute. Where is this? The nano. Okay. Git config. Yep. Okay. Global. Yep. Okay, that's Cool. Okay, cool. Okay. Yep. Just give me a minute. Yep. Okay. So what we're going to do now, you can see if you want to check out about what username you have put in your ID. So I'm just going to show you with the one which is user.email. So it's going to show you whatever the email ID you have provided or whatever the particular username you have used. Any point of time you feel like you stuck with particular command, you don't understand like what is git config is doing, you can just use git help config for particular config. You can just type git help with the particular, like if you don't understand what is branch is actually used for, or if you any point of time you don't understand, or you can just use man git. If you're using the git bash in Windows, every command is going to work same because it's using the Linux terminal. But if you're using the GUI, that is going to be different for you guys. But for Mac, Windows, and as well as for the Ubuntu or the Linux users, you can follow the same type of commands to understand everything. For any point of time you stuck with any command, you can just type the git help for particular branch, config, whatever the attributes you want to put here. Okay, so what I'm going to do, like I have already created this directory, and for you guys, I have already put some of the content already inside this thing. So now you can see like in this particular directory inside the libgit2, we have some of the, so many files like you see. Just assume this is your project where you're working on, and this particular project, you have so many different files. You have README sources, scripts, examples, YAML file, so many things inside these files. So now what we're going to do, before I move on, I'm going to show you something before. Okay. Now, for the first thing you always have to do whenever you clone the particular directory, because I have already cloned here. So after cloning, you have to check whether your git is already initiate or not using the git init command. And now you have downloaded the particular directory, you're working on a project. Now what you want to do, you get to know that some of the things you want to change in your README file. You don't understand, you want to change something, and then you want to push it back to the server, or server in the sense like GitLab, GitHub, Bitbucket, or anywhere. So let me just add something like here, the version 1.0. Oh, okay. I'm just adding a small changes here. Let me just save it. Okay. So I just added change some things. Now, if I'm going to type git status command, it's going to show me that you have made some changes. So if you see here on my branch master, it's going to say your branch is up to date, but it's going to show me you have modified the README file. So what does it mean? I'm going to tell you. Now I'm going to go back here and going to explain you about this thing. So what's going on here? So now you understand like how the whole Git repository, every time whenever you initiate a Git, it's a hidden directory is going to be created, which is called the .git directory, where every file, pointers, database, every information of your particular project is going to be stored. Now, inside the particular, typically, whenever you're working, you will have to start making changes. You're going to commit any snapshots or doing anything. It's going to do like this. Remember, like having three parts. Like now, if you see here, okay. So if you see here, like we get to know that we have modified some of the changes, but we didn't put it in the staging area. What does it means? Every time like you have like you create a new file, it's going to go under the untracked files. Untracked files are those files which is in your working directory, but it's never be recognized by Git. So I'm just going to show you right now. Let me just create a new file, demo txt. Okay, this is a demo file. Okay, so I just added a new file. Okay, so if I'm going to do the git status now, so if you see, we have one modified file and we have one untracked file. The untracked files means Git has detect your file, but it's not inside the staging area, or it's not been tracked by Git right now. It's just inside your directory, which is placed. But this file, which is the README file, which is already present because when you download the particular this repo or the project, it's already have this file. So that's why it is considered as a modified, but it's not in the staging area. To add this file or add any file inside the staging area, so you can use the command, which is the git add command. Now you can add one file at a time. Like if you want to add the readme file, once I'll add the file, now this file is moved from the readme.md, like it's moved from the modified to the staging area. So if I'm going to the status, it's going to be green now. Now, once it's green, now you can put the commit command and then you can commit or do other changes. Now you're saying to the Git, I have modified the file, which is already existing in the particular project. Now I'm doing what? I'm just modify the file. Now I add the file to let you know that I have added the file. Now I can do the commit. But if you just do the commit before adding the file, it's going to go back to the previous version rather than this version, the new version where you modified the actual file. So, but still we have seen one of the demo file, which is I created just right now in this particular directory, which is not anywhere in the Git side. Git don't even know that this file exists for him. That's what I'm saying. So if you see here, like I mentioned already, like the track files are those files which are the last snapshots. These can be unmodified, modified, or in the staging area. But the track files are the files Git knows about. And the untracked files are those files which are like totally unknown, nobody knows about except your directory and you. So if you want to add this file into the staging area as well, so you will have to add the command. And if you see Git also recommending you, please use git add.file. So what I'm going to do, I'm going to add this file as well. Now this file is added, so you can check the status of the file. So it's saying green, and it's saying you that all the files are inside the staging area. And now you can commit if you want to commit. So I'm just going to type commit. And note, when I type commit, it automatically open my nano editor, which we already, you can say, put in at the starting point. Like we just initiated in the starting, we set our inbuilt editor as nano here. So I use the nano in the starting. That's why it's automatically whenever I'm committing. So I'm just saying like here, okay, this is my first commit. Anything you want to type, I'm just type anything. Okay. So I just added and do my commit. This is my first commit. Now the commit has been done. Another way you can, and most of the time you use, is using the git commit. If you have ever used git in before, using the -e message, using whatever the commit you have made it like this. Okay. Now I'm again going to modify any file, like you get to know, oh, okay, in the nano.readme file, there is some changes you want to do because your manager said, we need to modify this file because we are doing something changes. Okay, so, okay. So something like that, you just do some changes and now you want to save this particular file. I save the file, and now if you check again the status, it's going to be red because now the file is already known by Git, but it's again, you modified the file, and so you have to add it again before committing. So if you say here, like it's saying, use the git add or git commit -a. So this time I'm just going to use the git commit -a command. What this command is actually doing, rather than doing in two steps, like first you add the particular this git readme file and then you commit, it's better to do it in one line using the git commit add, and then you are going to type -m for the message, like second commit, something like that, whatever you want to type in the commit message. So now if you see, I didn't add anything. I'm just using the one line and adding the readme file directly inside the staging area to the database. Okay. Okay, that's clear. That's fine. Okay. I hope you guys are getting it, like what's the point of Git and why we are using it, what is the distributed control version systems, how this came up into the idea, why we are using it. So just in terms of simple terms, like you are a developer in your project, your manager said, okay, we are working on this particular project, and now you are on the production side, somebody's on the development side, somebody's on the testing side, and somebody's on the Azure pipeline side. Just imagine so many people are working on so many different, you can say, the branches and different categories. And now some issue came up through the particular project. You're working on your local PC, somebody's working on their PCs, and now everyone's need to be collaborate with each other so that everyone get to know what changes you have made in the last particular Git, or whatever the changes you have made in the repo, so that we can see each other, collaborate with each other, and fix the issue. That's how the actual reality of the Git works in the real time. Okay. That's it. Now I'm going to talk about, I think this one is I already finished. Okay. Let me just see what are the files here. Do we have the Git security file? Okay, I'm just going to create a new file. Okay, there is no security file, right? Okay, we have the security file. Okay, let me just do some changes in the this security MD file, which is already been provided from the project which I download, or you can say clone it at the starting. So what I'm going to do, I'm just going to make some changes in the particular security file. Okay, this is my security file. Anything, I'm just doing random changes right now, because every time you make even a single or even a space, you do any changes, Git going to recognize it. Simply, I just write a one line and Git recognize it that you have made some changes. So, and why it's saying modified, the reason is saying modified because this file is already, when you clone it or you download it, if any file, when you download a project from the GitHub or GitLab or Bitbucket or anywhere from the server, any file which is already been downloaded from there, it's going to be considered in the modified, like it's already recognized by the Git. So it's not going to say untracked file. Git already know about that file, but now you just modified that file. Okay, now I have modified the file, and you can just do something. But before that, I would like to show you something about this thing. This is a really good thing, like when sometimes the file comes in two ways. Okay, let's just see the status. We already see the status. Okay, now let me just add the file. Okay, just give me a minute. Add security MD. Now check the status. Okay, now the file is added. Okay, let me just change something. Okay, this is version 2.0. Anything, just add it. Okay, just give me a minute. Okay, so this is a really good thing. Like now, if you see here, the same file is inside the modified, and the same file inside the modified, which is not in stage area. Now, how this is possible when you are working on the same file, one at a time, it's showing you that this file is inside modified with the green tick, and another time it's saying unmodified in the same thing, like unmodified, modified with the red tick. So what is happening here, like I have the security MD file, which is already present here. So this is the security MD file, which is already present in the directory when I download this particular project. I made some changes. I add the file, so it's added to the staging area, but it's not committed yet. So that's why it's in the green area. But now, before committing, I again do modify the file and do some changes and put it here. So if I do the commit right now, it's going to be committed this one, not this one. If I need to be modified to the latest version, you have to add the file every time. If you're not using the git add command for the security, it's going to be add this one, not this one. Git never going to add this file until unless you add the git add command. So right now here, I'm going to repeat myself. Maybe it's confusing because it's having the two same file with the same names. And so what's this going on? You have the directory, this one. So let me just clear it so that you understand better. Okay. So when you download the project, you have the security.md file. This is a file which we already have. This is the file which already we have. Now you made some changes, you add the file to the staging area. Staging area is nothing, it's a kind of an area where you just, after like whenever you add the file, it's going to be the staging area, and then you can commit it to the database. So now you have the state file which you already modified, you add to the staging area, but now you remember, oh, I have to make one more changes. Now you add again, you open the file, you made some changes to the security.md file, but now the issues arises like, now you just going to do git commit. It's going to be committed with the version 1, not with version 2, because you didn't add this file unless to the staging area. If you're not going to add to the staging area, it's not going to be considered by Git. Git only going to commit those files which are inside the staging area. Always clear these things. Like you have, just imagine like you have one is this one. Let me just show you if I have the figure of this thing. Yep. So it's like, this is in the working directory, you have this file, the same file, and you have the same file with the version, the previous version in the staging area. So this file with the modified version is inside the staging area, but you add one at the time you add this one like 5 minutes ago, but after 2 minutes you get to know, oh, I have to make some more changes in the security.md file. So this file, you didn't add it to the staging area, so this file still resting here. So it's the same file with the two versions right now. One is in the staging area, another one is inside the working directory. Now, if I'm going to commit this file, it's going to be inside, only this file is going to be go inside the .git directory, not this one. So whatever the changes last you made in your file, it's not going to be reflected on side the Git directory or inside the Git database. So you, every time you have to commit the file to see the changes. That's why either you can use this way through which you're going to add the security file. Now, if I'm going to see, you will only going to see one file, which is inside the staging area. Now, what does it mean? We moved the file from working directory to the staging area, and whatever inside the previous version of the staging area, it's now removed, and we overlap with the new version. Whatever the latest changes we made inside this security file, it's now going to be reflected. Now you can do the commit command and everything is going to work. Same, like third commit, something like that, whatever you want to commit, easy. So now it's going to be commit. Now you're going to see the status, nothing is there. You're nothing to commit, work tree is clean. Okay. Okay, so I hope that part is clear. That's a really good concept, but some people like never realize this thing happen. Okay. One more thing like you can do, like I'm just going to add it again, the security files to show you something. Okay, so this is something, I'm just adding random stuff. You can use git status -s command if you want for checking about the short descriptions. Like if you're not interested in seeing the full directory, like you're not interested in knowing everything, you are just interested in knowing whatever they're doing. So what this M represent here, I'm going to show you. So if you see in this picture, I have A and M, but and actually the git means with if you see the question mark, that means next to them. So it means like the files added to the staging area. If you see A, which is modified files for, and if you see M, which is for the particularly for like if you see M here, that means you have file in the modified area. And if you see question mark or something else, different type of characters, it represents to different things. So I'm just, it's in my one because we already have a file which is modified. I'm just going to show you one more thing. So let's just create a new file in a particular directory. So let's create demo2.txt. This, okay. So git status -s, you will see question mark, which means this file is an untracked file. So if you see here, so it's going to show you like the untracked file. So untracked files is going to come with a question mark. Modified files is going to come with M, and so on with the different characters. By default, if you have ever noticed, Git is so smart and so good with these things. Git knows like which file you want it into the staging area and which files you don't want it into the staging area. So Git comes with this thing with the Git ignore. This thing is really good. So Git ignore is a kind of a hidden file which automatically not going to ignore all the files which is like inside the build directory, which is start with ending with the ds_store, any file from your home directory, .star, tags. So these all files is going to be automatically ignored by the Git command. You can, if you want, like you working in your particular directory, you want to like you have different files with the different extensions, like you're working with a Python, Java, or you're working in the front end with the HTML, CSS, and you want only the files you want to commit or put inside the staging area. So like you just want like HTML files, you don't want CSS files or the JavaScript files inside the staging area. So you can add this git ignore file, and you can just put whatever the like you want to ignore, whatever the files, and Git will automatically going to recognize it for you. So this is really good, and you want to specify like only. So there are two ways can be possible. Either what you will going to do, like if you have multiple purpose programming languages like Python, Java, and you want only the Python files to be moved to particular staging area inside the particular project. Either you can move all the files outside the particular directory and then you use the git add command or the git commit command, whatever the commands you want to use. Otherwise, you can put the files inside the git ignore file, and then it's going to be ignored by Git automatically. So this is a good command if you want to ignore specific files which you don't want inside your project or inside your staging area. Okay. If the git status command is too vague for you and you want to know exactly what you change, not just which files were changed. So like the git status command, because right now we don't have anything. Okay, we have anything. So you see right now, you just see the files. You don't see what you changes inside the files. And you're now interested in what I made changes inside the files rather than just the name of the files. So you can use git diff command. It's going to show you exactly, like I just wrote it this thing in this particular security file or in the demo file. So it's just going to show you the difference, whatever you added inside the particular file. So you can use git diff command in that case, like if you're just interested in knowing what you have modified in particular file. One more thing, git status is only going to show you which files are unstaged at the moment. If I'm just going to commit this files, let me just commit. So if you see git status, now everything inside the staging area. So if I'm going to run git diff command, it's not going to show me anything. Why it's that? Because now git diff is only going to show you which files, which is untracked files at the time, which is you didn't put inside the staging area. But once the files you already add to the staging area, git diff is not going to show you anything. But if you are still interested in knowing what is the actual changes you made, so you have to specify with the ---- or ---- for the stage. So it's going to show you, now it's going to show you what files inside the staging area, whatever the changes you have made. So you see this file, which is the demo2 file, which we added. Now we have put inside this particular staging area. And now we are seeing the difference, whatever the difference or whatever the changes we have made in this file is going to be inside the staging area. And we are seeing that differences here. See, this is a demo2 files and everything is coming up. Okay. Okay, now git commit I already mentioned, like, and I show you the new way, like if you never use it before. So like right now we have everything inside here. I'm just going to show you one more time. Just create a to-do txt file. I'm just creating a random file. This is a ts file. Okay, so just add the file. Okay, so I just create this new file. So this is a TS file, something like that. Now you always have to add. So in one line, you can just type git commit -a -m. This is the this is a TS file directly. So rather than typing in two lines of git add TS file and then you add this thing, you can do it in one line with a git commit command. So it's a really good way. Like if you work a lot of different files, you can just rapidly add with these things. Any point of time you are interested in knowing about, like when you're going to work in an industry, most of the times you download a project, you want to see the logs, like who done what at the time. Like I'm working on a project as a developer, somebody's working in a production environment. Maybe I want to see what changes he has made on what files. So git log is a really good command. When you worked on your project, maybe you're going to see a lot of different logs, or maybe not, depending upon what changes you have made or what other people's have made. So if you see here, like in my one, and this is the one which I'm talking about in the starting phase. Like I said, every file in the Git is considered as a 40 character hash value. And whenever any commit or you change any file, it's going to refer to that particular this thing. This is the 40 character of a SHA -1 value, which is called as a hash value, which is going to be referred in the database. So Git always going to store these values, and whenever you search for any file, Git always going to search a file in the database based on the hash value, not based on the file name. Always remember this thing. Also, head is nothing. Head is a pointer. You can consider it as a Java if you done it before, or any programming language. The pointer is nothing, it's just where it's pointing to. Currently it's pointing to our master branch. You can change the name, or you want to do anything you can do, but right now the pointer is pointing to the master branch, and it's showing about the author name as well as the particular date, whatever the changes I have made. If you see here, these are all the changes I made. And if you see here, somebody else, the Patrick have done some work, whose author name, what date he has done, the merge pool, the descriptions and everything. So git log is really good command if you want to see, like you worked on some project, you download, now you clone the particular project in your local directory. After 2 days, you want to see what people has done what, or you want to know, okay, what changes they have made, so that I can see the changes and then I start moving forward. So this all things happen when you're going to work on a one big project and everyone working remotely on their homes or in their offices and just want to collaborate on one place. So git log is a really good command. So like right now, like with the git log, you see a lot of logs, but you're not interested in all of them. You can restrict yourself with a good git log -p for the patch. Patch is going to show you whatever the difference you have, and -2 is just going to show you about only the first two commands, which are the latest ones. So if you see here, so it's just going to show you whatever the patches, like whatever the changes I have made in the last, because I have just latest changes and nobody's have done anything apart from that. So that's why it's showing my name. And if you see with the -2, it's going to show you only 2 of the files. And this number is nothing, like I said before, like it's a 40 character numbers, which is start from 0 to 9 and mixed with the A to F alphabet characters, which going to be used by Git for storing the files, or whenever he has to search a file. It always go by the hash value, never by the file name. Okay, I hope that part is clear. You can use log, you have learned about Git, you know Git init. So every project, so what I'm going to do right now, just to remind you, let's just see, we have so many things. Okay, let's just create a new directory. Okay. This thing, I'm going to start with the branching, then I'm going to do this thing. Now in terms of Git Remote, what is a Git Remote? Now, to able to collaborate on a Git project, you always need to manage your remote repositories. Remote repositories means like somebody have some repositories on the server, on maybe on GitLab, GitHub, or anywhere on the server. It's not only these three, like maybe on Amazon, maybe on Google Cloud, anywhere you have repositories where all the developers are collaborating. So you just have to see like, and so remote is this particular repository. And the repositories versions of your projects that are hosted on the internet, as I said, you can have several of them, each of them like generally either or read, or some you have write permission. So maybe you have the read permission and write permissions when you're working locally, but you don't have permissions to push it back onto their servers. So this can be happen. If you are interested in knowing about the URL as well from where you are fetching the particular repository, you can use git repo-v. So it's just showing you this is my origin and this is the actual URL through which I am referring to right now in this particular, whatever the files I have. So I have to taken from this particular repository. Okay. Yep, you can add a particular remote repository into your local PC. So for that, you can just type git remote. And so just say, let me just use the same name, Git DSC. And then you can type the whole name. So what this command is going to do, I have to type the whole name. Okay, just give me a minute. github.com, Paul Bonnet. Okay, git. I believe if I write right. Okay, so I added this DSC git as a remote here. So I don't have to type every time the whole URL. I just can refer to this DSC git. So like, so every time, like you don't need to write the whole URL. You can just refer to DSC git, which is automatically going to fetch the data for you. So let me just get git fetch the git. So it's automatically going to be now whatever the files on that server is automatically going to be downloaded inside this particular directory. Maybe it's taking time because its file is too long. I'm not sure. So now you can see that its file has been downloaded from the server. So this is another way, like if you don't want to put the whole URL, you can just add the remote repository as a small abbreviation. Like I just added the DSC git, and then you can just fetch from that. So it's automatically referred to this particular URL. Any point of time you want to inspect something about the remote, you can just type command git remote show origin. It's going to show you the actual origin of the file, like whatever the changes have made. This is showing you the official fetch URL, push URL, what is the head branch, remote branches. They have so many branches. So you can see a lot of things like, and I'm going to show you for the another one, which I have the DSC git. So similarly, we can see from the another branches. So this all things going to start seeing to you when you have so many people are working on the same project and everyone is collaborating with each other. Okay, tagging is really a good tool, and I'm going to talk about tagging as well. So tagging comes into the play when you have like you're working on a project. Now, let's suppose you're working on a project with an example. Just take an example that you have building a website. Now, in the website you're building, you get to know that some issue comes up because a lot of user traffic is coming up to the particular website and a lot of users just hitting the website, and your site or the server is getting down. And then your developer teams or your production team contacts the developer teams and saying, oh, Mohit, we are getting this issue, please resolve it. So now you can do one thing. Whenever you fix any major issues, people use tag in that way. Like you use iOS phone or anything, whenever you see the particular updating version 1.0, 1.1, that's all the tagging basically. So right now, like I'm going to show you a lot of tags in my particular this win. Maybe you don't have not even a single one. If you don't have, don't see any output. So what you will going to use tag for, basically, you fix up the particular issue or the bug in particular website, and then you're saying this is a major update. And when you're saying this is a major update and you want to recognize to the people whoever working on the same project, you can tag them and you can say them, this is the major version. I have made so many changes. So now this is considered as version 2.0 or something like that. If you're making a minor changes, so you see like a lot of minor changes, 26.5, 4, 3, 2, 1, so many changes. So depending upon your project and everything, you will start using about the tags. Tagging comes in two ways in Git. One is the lightweight and another one is the annotate weight. A lightweight is a very much like the branch that does not change. Like it's just a pointer to a specific commit. It's not going to show you too much information. Another way is the annotated way, which going to be show you like the full objects in the database, and it's going to show you about the checksums, contains the tagger name, email, dates, and everything. So we're just going to create a tag now. Let me clear this. So you have seen like we have a lot of tags here, but I'm just going to create a new tag so that you can see tag. These things you're going to use when you're working in a real life project in industry, when you have a lot of projects going on and you may fix up some major bugs or issues, then you will going to use a lot of tagging. So in terms of tagging with the annotate one, using the -a tag, and then you just say, till now we have seen only 0.26. So I'm just adding some major changes here with 1.0. I can tap some of the major things like major change in the particular project. That's it. Now you will see in the end, this one in the end, like, so now I just added the 1.0 here. So it's going to show you directly here. But the one thing which you want to see, like what tag you just added. So we added the 1.0 here. So you are only interested in whatever the changes you have made in the tag. You want to just show yourself, you want to check it out. You can just type tag and the tag name you just added. So sorry. So show 1.0. So you can see what this is the tagger name, like you will see, because I use the annotate way using the -a above. So that's why it's showing about the major changes in the project, whatever the changes I made it. And it's going to show you about all the checker sum, also the pointer where it's pointing to. Now I added the tag to the particular who's the author name, date, whatever the changes I have made, everything is going to show you. So tagging is really good when you have some made some changes and the changes are really important and you want to tell other people to see the major difference between the different versions of the product or the development of project. So you can use tagging in that case. Lightweight is the another way. So I already told you guys, like we have two different ways. One is the lightweight, another one is the annotate. Annotate, where you use the -a one, like this one is the -a, which is representing for the annotate one. And in the annotated tag, you have so many informations regarding the tagger, dates, whatever the changes you made, the commit, about the 40 checksums, hash values, authors, everything you are going to receive. But another way you can use the lightweight, which is just going to show you some of the difference. I didn't see you guys are asking some questions. Okay. Guys, if you have any questions, I'm sorry, because I'm just representing, sharing my screen, so I cannot see the questions coming up. Once this workshop is going to finish, you can ask the questions, or maybe Kunj going to help you with the questions if it's simple questions you have, anything of that. Okay, so where we are right now. Yep, so now we have created with the annotate tag. So I'm just going to show you the another way, which is the lightweight tag you can create with the normal tag, like just not with the -a, which is for the annotated one. Now we're just going to create a simple tag. So just say 2.2.1. I'm just going to put a name lightweight so that we can easily recognize. So if you see here, you can see in the end, which I added the 2.2.1 hyphen lightweight, which is for the light case. So if you want to see this particular tag 2.1, so you can see it's not showing about the tagger name and everything. So I'm just going to show you the difference, main difference. I believe this is the one. So you can see the difference between the both of them. One is the lightweight, this one is the lightweight, where we don't see the tagger name and details of the data, but here you will see the taggers who tag that particular tag on what date and everything. any point of time, like you forget, like you just working on some of the particular this thing. So let me just show you, like git hyphen pretty one line equal to one line. Sorry, git log hyphen equal to one line. Oh, sorry, my bad. Yeah, so you can see like there's so many right now, the logs with the, so what I have done, it's just nothing, it's just show you in the pretty way. So whatever the commits or the messages we have along with these 40 characters of the hash value. Now, any point you remember or you recognize, oh, I have to tag this particular hash value to tell them people that I have done some major changes, and you forget it at the initial phase. So you can just using their hash numbers, you can re-tag them. That's called a tagging later on. Like if you want to add a later tag, you can do that. Okay, so let's just do for this one. For you don't need to type the whole number, like 40 digit. I believe only 5-6 characters can easily recognize this thing if you want to tag in right now. So what I'm going to do, I'm just going to do the git tag -a. This is like 3.1, let's just say for easy. So I just add this number to this particular tag with the different stat, fix the segfault with the new files. So now the tag has been, like I'm saying, this is the version 3.1. I just added the tag. Now this tag has been added to this particular, this one, which we have seen here. So now if you run again, you will going to see that particular tag here. Git show. So you can see this particular tag, which is added by me in this particular file. So this is the EC2, again, the one which we pointed before. So now the tag has been attached to this commit. So anytime, any point of time, somebody, the developer or anyone wants to see whatever the changes you have made into the script or into the particular program you're running on, you can and see the checks. Okay. You can also share the tracks. This particular workshop is dedicatedly focused on local servers. So I'm not going to work on the GitLab, GitHub, or any servers on like AWS, code repos, code commit, anywhere. So this one is just focused on how you can play around with the local server in your local directories. Once you have the understanding about creating a Git file, cloning them, initiating, check the status, merging, and everything. In the next week, we're going to totally focus on how you're going to work on the remote servers. So just for right now, like I know there's a lot of theory part right now along with this thing. So once you have better understanding about how Git actually works and why Git came into the market or into the industries and why we are using this kind of a versioning tool, then you have better understanding. So why should we use it and how we're going to use it in the remote servers anywhere. It may be in AWS, wherever you want to use, you can use Git. Git is really good tool, but now the competition has come with the GitHub, which they also launched their own CLI. So it's going to see, let's going to see how much Git CLI going to compare to the GitHub CLI now, because GitHub CLI is also getting boom, but it's only, they launched an official version on September 17, which maybe some people in the industry is using and some people don't. So it depends upon the people to people. Okay, one thing which is really good with the Git Aliases, like if you have every time like you just typing Git status command and you don't want this command, or any point of time you want to add some commands according to your own needs, like you think why this command is not there, Git provides you this feature to add your own commands. You can add any command which you think this must be a command, why they didn't add this command to me. So you can add the command, or you can change the particular Git status command to Git st. So I'm just going to show you one, because I just have to worrying about the time as well, because the time is running fast and I have a lot to cover. So I'm just going to show you the st command for the status. So now what I'm doing, I'm saying git config -- global, then I'm putting the alias as st rather than status. So what this command is actually going to do, I don't need to type status anymore. If I'm going to run the st command, it's automatically going to show me the same result. So any point of time you feel like you want to add any command, you can add anything, or you want to change the particular alias of the particular from status to st, or here I have done some of them like br for branches, ci for commit. You can change according to your own need. Now let's come to the last topic before of this workshop, because the time is really less for me. Okay, now Git branching. Some of you have used branches in your day-to-day Git life, or some of you don't. I'm not sure about my audience right now. So right now, like if you see about the master, and if you see this pointer that's referring to that you only have master here, which is like this pointer is just referring to the master and it's pointing to the master. So what we're going to do for these things, what I'm going to do, I'm going to explain with this scenario, what is going on. Let's just create a new directory. And whatever I have done in the past, I'm going to follow the same thing here. Okay, let my DSC. I'm just creating a new directory. Let's just go inside the directory. The directory is currently empty, so we have nothing inside this directory. So what I'm going to do, going to initiate with the git init command. Every time you just initiate with the git init command, it's going to create a hidden directory. So now if I'm going to run this again, you will see the git init directory. And whatever it's git init is like kind of a database you can refer to, where everything, whatever the changes you're making, whatever the pointer you're pointing to, whatever the hash values, everything is inside going to be stored inside this particular git. So you can see a lot of different, like whatever the branches you have, config files I showed before, the head is for where the pointer is pointing to, objects, reference. So a lot of things. If you want, like I can make a whole another session on this particular git directories where I can explain everything about the different folders and what they represent. But let's just come back to the focus. Okay, so right now it's totally empty. Only we have the init initializing, because we initialize, so we have the empty git directory. Okay, so I'm just going to add 3 of the files for this purpose. Let's just create one is the license file. This is a license file. Okay, let's just add the file. Now I'm adding the readme file. This is a readme file. Okay, and now I'm going to add one more file, just take for example, because text file. Okay, this is a text file. Okay, so I have created 3 files. Now the first thing, like you notice that you have init directory. Now you see that you have 3 of the files. Now if you check the git status, it's going to show you all untracked. That means all the files is currently present inside the working directory, but none of them is like modified, or none of them is automatically added to the staging area. So if I'm going to try to git commit, it's not going to work. It's going to show me the error. Anything I'm going to do, it's not going to work. I have to first commit before that. Like I have to add them inside the staging area. So right now, so we have 3 files. So what we're going to do now, so just imagine like these files are the files with this is the particular hash values. So just assume like the snapshot A is the text file, snapshot B is the particular readme file, and snapshot C is the license file. And your master is pointing towards the one of the file. So let me just show you this thing. Just give me a minute. Okay, so let's check the status right now. So we have all are there. So using a git add command, I'm going to add all the files from untracked to the staging area. And using a dot command, you are saying whatever the files you have in this particular directory, add it to the staging area. So now all the files are added to the staging area. So you will see all green check. So it's saying everything is now added to the staging area. You can commit now. Okay. So what will I going to do? I'm just going to add the tag command as well for one of the file using the annotate version, just to show exactly what's going on in the Git branching here. So what I'm going to do, just say 1.0, just for this thing, my version 1.0. I think I don't need to tag this. Okay, so I am just saying git tag with the annotated tag version 1.0 -m. Then I'm putting my version 1.0. Okay, that's it. Fail to resolve. Oh, okay, sorry. I have to type this thing as well. Git tag -a-1. Okay, sorry. First, let me just commit some. First commit. Okay, so I just committed the file here. So first of all, let's just see, we have one branch, which is the myDSC branch, which I created at the starting using the .init file. You can create any different master name or whatever the name you want to give to your main branch, anything you want to do. So I have the branch name, this branch name, which I have created. So let's just create a new branch, Git branch testing. So now if you're going to see, it's not going to show, I believe it's not going to show you. Oh, okay, it's showing. Okay, so if it's going to show you, but it's pointing to the myDSC master. So myDSC master, it's pointing, the pointer is referring to this one, and where we have all these files. So if you see, we have 3 files, and the 3 files of them, the master is pointing to one of the file right now. So now what I'm doing, I have created a branch. Now what I'm going to do, let me just check the first logs, and then I'm going to show you how we can switch the branch and work on that and come back to the same branch. So now if you see what this command is showing, because we don't have too many logs right now, because I just do one commit. So it just show you the head is pointing to the myDSC master where we have one commit. And this is the actual hexa value or SHA1 value for this particular branch. So this is the same value like you are seeing here in the right hand side of the screen. Now what I'm going to do, now we know that our pointer is pointing to the myDSC master. Let's just switch to the testing of them. Let's just change to the second one. So now if you see here, like, let me just see. Let me just make some more changes before we move on. So let me just change some of the file. Okay, license, okay. Version 2. Okay, let me just make some more changes. Okay, now I have modified, I have to modify the file, just add, let me just commit. Second commit in the license. Okay, so now I have made the changes here. Let's just see the logs. It's going to show you add one more log which we added. So currently it's added the first commit here, second commit here, but the pointer is pointing towards the. So if you notice here, now the pointers move from the head, which is a pointer, which is moved from the testing from this commit to the next commit, which was the latest one. And now what we're going to do, we're just going to switch back between the particular branches, and then we're going to come back and see how it's going to work. So, so we have done the Git status. We have checked everything. Let's just check it again. Everything is clear. Okay, perfect. Okay, now what we're going to do. So Git branch is still pointing to DSC. So using the Git checkout command, you can, I think I have given here as well. You can check the Git checkout command. It's going to switch back to your different branch if you have. Okay, anyway, I didn't able to find here. I don't know, I didn't provide it or not. Okay, just so let's just change the branch. Okay, so I'm switching branch from my master to anything. Now I again going to see all the files. Now what I'm going to change the files. So now I have this file. I'm going to change under the testing file. This is a testing file. Okay, let's just save. I believe it's saved now. Okay, so now it's saved inside the testing file. I've made some changes, but I'm working on this now. If you see now, our branch is not anymore the my DSC master. Now it's changed to the testing. So if you see now, the head is pointing towards this pointer, like the pointer is pointing towards the head, or you can check it from here as well. So now the pointer is pointing towards the testing branch rather than the my DSC branch. So what we're going to do, let's just add this particular file, which we just added. Okay, now if we see the Git status, so it's automatically now we have added the new file. Okay, let's just commit -m, second test file. So now the file has been committed. So now let's just switch back to the main branch, which is the my DSC. Okay, now if we see the logs here, now we again move back, but now if you see the pointer is moved from the particular testing to again to the main branch, which is the my DSC branch where we have just added a new commit, whatever the changes we have made. But if you notice here, we committed the file of the testing file, but the pointer is pointing again on the first one, which is the second commit in the license. It's not pointing towards this file. And it makes sense, like if you worked on like a particular, like you have two branches, one is the main branch and another one is the testing branch. And now you made some changes from the particular main branch, like you update some file, you made some changes in the file, and now you commit the file, but your pointer, which is pointing towards the main file, it's not going to show. So what I mean, let me just show you from here. It's going to be better clear if you see this side. Okay, so what I have done here, see, I have just created a new directory, then I am inside the directory, I have initialized the directory, then I have created 3 of the files, and then I have listed the file. You can see the file. You can see when you first time you initialize the Git directory, you will see the particular hidden directory inside the Git where all your data, all the header pointers, database value, hash values, everything is going to be stored inside that particular hidden directory of Git. Now, since we have just created the files, we have added some content inside these files. And now inside these files, we have seen all these are pointing towards the my master, because at the time I'm using my master, which is my main branch. And all these are untracked files because none of them we have put inside the staging area so that we cannot commit. So first we have to add. So we just add git add dot command, which will going to add everything, whatever we have inside that particular directory. And then we have using the git status command that is showing us that everything is now inside the staging area. You can commit now. So these 3 files are like these files, which represents to the hash values of each of the files. One is the license file, one is the read files, and one is your text file. So each file is there, one of the master, and it's pointing to the my master here. And the head is pointing towards the my master, and the my master is pointing towards this. I think I didn't show about the tag here, but I think I have added the tag here. So if you type the tag here, this for particular thing. So I just added the 1.0 tag here, and then you're going to see whatever the tag you have added. And in the Git branch testing, which is going to create a new testing. And when you're going to type Git branch, it's going to show whatever the branches you have, and the star representing that my master is your current branch where you are pointing to. And with this git log -1 value decorate is just going to show you the actual so this is just showing you exactly the same thing this picture is depicting. So what is going on? The header, which is your pointer, which is pointing towards the my master branch with the tag value of 1.0 along with the testing. And so if you see here, so this is our tag, which is, the head, which is the pointer. This is our main branch. And this master branch is pointing towards this particular file, or you can say the hash value. So this pointer is not pointing towards the testing, it's pointing towards the my master, which is the main branch. And similarly, then this thing, what we have done. So after this thing, we switch to the, we said, okay, master, you're pointing to that file. Now I want to switch back to the testing. So I just have another branch. So I just check out and go inside the testing branch, which is pointing to the same file, which is the license or readme or the test file, any file you can point right now. So both of the master branch and the testing file is pointing to the same file, which having this file, or you can assume this file as a readme file or the test file right now, just for the case, because we have 3 files only. And then what you done, you have the head, which is pointing towards the master, but you have switched back to the testing now. So now what we have done, so here I'm showing about the Git logs, which showing you about the testings and everything, like what initial commit you have done. But now using the Git checkout, you can change your command. So I changed my switch back. So I changed from using the Git checkout, you can switch between the branches. So that's exactly what's going on here. It just to switch. So now the pointer is not pointing anymore towards the master, it's pointing towards the head. I mean, towards the testing side, testing branch. So now the head from the master moves to the back, I mean, the bottom side of the testing branch. And the testing is now pointing towards this particular file, which is the license test or any file you consider right now, just for a case. So after that, I just do some changes in the test file, and I'm showing that I have some changes. These are the files, and we see that we have modified the files, and then you can commit the file. So I have made the commit, I have made the changes, everything is done. Now what is done, I have switched back to the, my pointer is now no more pointing towards the master, it's pointing towards the testing, which is showing here. So now the heading is pointing towards the testing for the version 2.0, whatever the test you have changes. So I have commit the file here, and now it's pointing, the pointer is pointing towards this version 2.0 test. Now, if you're going to type git branch, it's going to, the star going to point towards the testing branch, not to the my master branch anymore. So if you see, F30AB is the file which is pointing by the master branch, and the testing is pointing towards the F30AB. Both are pointing to the same file at the time, but once you create a new file or you do some changes here, so now the pointer is to the testing file because we are inside the test branch, and now we have made some more changes inside the file. So that's why it's creating a new file. And now if you want to switch back to the master branch, then the head again jumps from here to come back to the same file where your master is pointing to. So that's it. That's going on in the Git branching right now. And in the last, like I just do some commit again in the changes in the my master branch. And now you can see the files are changes again, the submit some changes. And now you can see here, the using the git log - one line decorate all, it's what it's doing. The head is again moved from here to on the top of the master again. Head is nothing, it's just a pointer which is pointing towards either to the one of the branch, either a master branch or the testing branch. You can create any branch according to your need. So, and if you want to see this particular graph, like how this whole thing is working, you can type like git log - one line decorate graph all, which is going to depict the same thing what's going on here in the picture. That's it from my side, right, guys? I hope you guys have could get to know some of the insights of the Git, how it works, and how you can create the branches, or how you can, what is the versioning control, why we should use Git, how Git came into the market, and why people are using all over the industries. People love Git about it. And then we talk about the Git initiation, like Git init, Git status, staging area, how to commit, what is the Git different, or how to check the logs, what is the tagging, why it's important, Also, we talk about the branches, about like what are the different branches. Git branches is really important concept, and I'll going to continue the next one. The next workshop is solely going to be focused on the particular terminal. I'm not going to make any PPT because I believe it's really for you guys as well, for me to very confusing to explain everything by what's going on. So next one is just going to be directly going to be on the terminal, where I'm going to show you some of the real project when you're working in the real industries, how the particular, when you have multiple branches, like you will going to see like more than 10 branches you have. One is the production, one is the development, one is the testing. And some of the bug issue came up in particular testing criteria, because the testing team is working on particular branch, and they said, like, they notify us in the group that we got on this bug issue, can you fix it? Then they contact the development team. So development team will go inside the testing branch. They're going to see what the particular bug we have. Then they will go into whoever the developer we have, like the developer going to clone the particular repository into his local server, or you can say the local PC where he's going to work. After fixing the bug, he will going to commit every changes. Then he will going to put back to the server. Server can be anything: GitLab, GitHub, Amazon code repository, Google Cloud repository. So anywhere, Bitbucket, anywhere we can, they're going to commit back. And after this, once the issue is fixed, then the production team will going to see. And if they're seeing like, okay, the bug is really fixed and all the testing has been done, then they will going to merge back to the main branch. Thank you guys from my side. If you have anything, just either speak or message in the main group. Thank you. Jaskirat?
Hello, everyone. I'm Jaskirat, the operations lead of Google DSC at Monash University. Thank you, Mohit, for going through that workshop. And thank you, everyone, for showing up today for our first event. I hope you all learned something. As mentioned earlier, this workshop was recorded and will be uploaded on our YouTube page, and the slides will be sent out later. Feel free to follow us on our social media pages and join our Slack group for our future events and upcoming recruitment. I hope you all have a lovely evening.
Yep, guys. If you guys like interested in joining the development team, or we are looking for the people, especially from the marketing side, to for marketing or publishing more our particular group, so that we can bring more people and bring more audience, not from Australia, as well as from the outside Australia. And also, if you guys have time, please submit one survey, which is going to be sent it by you by the email. We have your email ID, so we're going to send you, so that you can provide us like what technologies you are interested in, so that we going to focus more solely on that. Like if you're interested in Google Cloud, you are interested in AWS, you are interested in Docker, interested in Kubernetes, you are interested in anything like Python, data science, machine learning, anything which you are interested in. Once we have the audience fixed, we'll probably going to bring people who are actually the industry leaders, and they will going to tell you more about like how the industries works with that particular project. Oh, hope you guys, you find something good from this workshop, and message us if you have any issues or queries. And for the next workshop, which is going to be solely on terminals regarding continuing, because in the next workshop, we're going to talk about rebasing, stashing, how Git works on the servers. Like I'm just going to show you with the GitHub and GitLabs. We again going to work with creating our own particular repository. Then we're going to start with putting some files, working on some kind of a project, give you the experience like how actually when you have multiple people are working on the same project, how you will going to fix the bug, use the tagging, how you will going to push back, and how they will going to merge to the main master branch or anything. Thank you guys. You can leave if you want. Thank you so much.